So what couple of things we're going to hit. We're going to do classes and object-oriented programming, which, you know, could take weeks upon weeks, but we're going to give an overview. And then if you want weeks upon weeks upon weeks of object-oriented programming, take Java. Then along with that, you know how we have the ability of doing something like this, print, blah, 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 and then you pass in some parameters, you know, like that, things that are going to be, you know, and then you do, okay, I want my separator to not be commas, but smiley faces. And then I want the end of my line to be, you know, a sad face, for whatever dumb reason. Okay, like that. I don't know if that looks stupid. There, underscores as our separators, and then, you know, asterisks as our end of line. And so when it printed out, it would print hi underscore 1 underscore 2 star. That's exactly what we told it to do. But what in the world is this syntax really? How do we do that? We haven't written any functions that would accept parameters in that syntax. And so we will look at a syntax that allows us to do that. As a matter of fact, maybe we'll do that first. Easier concept, well, not easier, shorter concept than classes and object-oriented programming. So far, our functions have looked like this. DEF test, you know, and they take a parameter like this. And you could print out X, right? You could do something with X. That's what our functions have looked like. So when we wanted to call them, we would just do that. What if we wanted to be able to pass in varying numbers of functions? I mean, because, you know, you can print out one thing, or you could print out two things, you could print out three things. What if we wanted to be able to accept multiple parameter lists? I mean, parameter lists of varying length. Well, we can do that. And that's not really discussed in either of our texts, but we're going to hit it anyways because it's really good stuff to know. So the way you do it, and this is going to look weird for you C++ programmers who are used to the idea of pointers. It's just one of those places where the Python syntax and another language's syntax look similar but are radically different in their meaning. Just live with it. Just know that a star means something different in other languages. So we're going to write a version of the test function called test2, but it's going to take a series of parameters. That is actually a list. For every value in X, print out the value with an end, with an end of nothing so that we can get them all in the same line, right? Maybe we should put a space after it. Like that. All right. Just so that we get, you know, some spaces between our values. And then after it's all done, let's just print out a blank line so it'll be done, you know. But we could have done anything with this stuff, right? We could have added up all the numbers, put them in a total, whatever we were doing with a list, you know. This is just list processing. We have a list here. We could change this to, you know, capital L. We've been using list for capital L, you know, or star list. Well, that'd be bad because, you know, a lot of textbooks show that. Args. These are the args to that function. So we can call it a couple of different ways. Test2, let's call it with one word. Hello, or maybe just the number 100. Let's call it with 2, 100 comma 200. Let's call it with no parameters, see what happens. We're not going to actually see any output from that at all. And then let's do it. This is just an example, but let's pass in a list. Let's see what happens if we had a little bitty list here. Red, blue, green. And I don't recall what this does, so I'm going to be curious as to what that does. I think I know. And then let's print a done message. So if I add some spaces to my print statements and make them absolutely clear. Alrighty. The tension mounts, I want to save it and run it. November 7.py. Okay, run. Alright. So the first time, yeah, all I did is print a 10 because we called the test function. But the second time, we passed in 1, we passed in 2, and all it did is it printed it out as a list. It accepted the list as one argument. And then so we only had, you know, for value in list, value was the entire list. If we wanted to iterate through that list, we could. But that didn't do anything good, so I'm just going to delete that. No, I'm not. I'm going to pass it in like this. I'm going to take the list indicators out. There we go. Now we see what it's doing. It worked with no parameters. It worked passing in 1, 2, or 3 parameters. You could list any number of parameters as you wanted to. So let's add a comment to that, indicating exactly what we've done. Use the star symbol to indicate that a variable is actually a list of arguments. Now, how is that different from what we've done before? We could have made a variable that was a list in the past, right? X could have been a list. Let's write one more. You know, DEF test 3, that takes a list, right? For value in list, print that value. Nothing too sophisticated. How does that differ from what we've done here? Well, if we were going to call that, you know, test 3, we'd have to build a list and pass in the values like that. Hello, goodbye, see ya, like that. Whoops, I forgot my list indicator. Like that. Or you'd have to build that list beforehand, like this. L is equal to that list and then test 3L. Either way it works, but it's uglier having to define a list before you pass it into a function. It works. You can pass things in as a list like that, but it's ugly. This syntax looks cleaner. You wouldn't really like it if every time you called a print statement you had to define the entire thing as a list. It just adds unnecessary clutter to the syntax. I'm going to add another comment up here. Variable is actually a list of arguments. My other comment is, so this can be invoked by test. Or test 2, sorry. Test 2 with some numbers. Test 2 with a whole bunch of numbers. You know. Whatever. That's how you define something with an argument list that'll accept varying numbers of arguments, just like the print command does. Then there's the ability, like of the print command. Don't type this, I'm just going to erase it. But we saw, just like here, we had what's known as a named parameter. And how do you define a named parameter? Instead of using 1 star, you use 2 stars. I think I'm going to scroll down underneath everything. Delete my print done thing. Okay. Use star star to define a dictionary of named parameters. Alright, I'm getting tired of the word test being our function name. So, how about, I don't know. Example. Yeah, that's a lot better. Example. Define example star star args. For some reason, a lot of textbooks I've seen use k args. Not sure why. Keyword args. KW args. Now that makes sense. So we could check to see if we have any keywords in there. If 2 is in keyword args, colon, print 2 colon, comma, or 2 colon, end quote, comma, and then you just treat this like a dictionary. Like that. I don't know if embedding it like that made it look good or not. I'm going to do it slightly differently. Let's do this. Sender is equal to default. Subject is equal to default. And then if 2 is in key args, then sender is equal to KW args, KW args. Oh, come on, type well. Square brace quote to end quote in square brace. Now let's get the subject out. We're just going to say that sub is our keyword for that. If sub is in our dictionary, if sub in KWRGS colon, then the subject equals KWRGS square brace sub, like that. Why are we doing this? Because we don't want it to blow up if they didn't call it with those parameters defined. You know, end and sep are not mandatory in the print statement. Now let's print out a message using that thing. Print 2 colon %s subject colon %s end quote. Now we have to pass in our tuple %, parentheses, sender, comma, subject. And then one final close parentheses. Let's see if it works. Example, let's call it with nothing. Oh, we need some kind of final print statement just to indicate that we're done with all this, right? Print, done with example, call. Oh, wait, no, we don't need to do that because it will just print out default. We will get some output no matter what we call. So I just remove that. So example, nothing, example, subject is equal to whom it may concern. example, the to field is equal to Dear Uncle Bob. Now let's fill in both of them. Example 2 is equal to Bob, and the subject is equal to, I think I'm going to have to separate those with commas. Yeah, I am. The subject is equal to, hi there. I'm going to go and put a comma between those two parameters. Let's see if we've done that right. L is not defined. Okay, yeah. Whatever. I added some stuff and didn't test it. That's because up here I said L, you know, with square brackets, but I didn't say L equals. Okay. So if you added that, you're going to have to make that correction if you typed exactly what I did rather than what would have been correct. Before the call to test 3, L equals square brace, list of values. All right, here we go. So here's our call. To default, subject default. That's when we passed in nothing. To default, subject to whom it may concern. To Dear Uncle Bob, subject default. So they specified the sender, but no subject. And here we've specified both the recipient, I think I said sender, and the subject. So hopefully that looks pretty cool. The ability to dictate what kind of information you're passing into it. And why might you want to do that? Well, you know, an email can actually have a whole bunch of parameters, right? Importance is equal to high. Sender is equal to this. Recipient is equal to this. You know, you might have something that takes in optional data where you don't have to specify it every time or not. Say you have some kind of data involving an employee and you want to be able to do something like this. You know, you want to be able to create a person, you know, file, or, you know, don't type this, you know, where first name is equal to Bob, you know, last name is equal to Thompson, you know, and their birth date is equal to, you know, 11/17, you know, 1978, whatever, you know, and you could list as many or as few parameters as you needed to fill out that object. Maybe you don't have all the information, you know, at that time. Just kind of tuck it away. Not all languages support this. I don't know how to do this in Java. I do know how to do it in C#. I think it's pretty cool. I think the ability to send in the parameters in whatever order is pretty cool. All right, was there anything else along this topic? Okay, I'm going to go back and put in a comment here. Use ** to define a dictionary of name parameters. And then, I guess, see below for examples calls. Good enough. Right. Is everybody working? Let me pause this. So a better example of why you might want to do that rather than the employee example I was giving is, I seem to recall, but I couldn't find it in the last 3-minute lookup of it, is that when you make a turtle, you could do something like this, turtle.turtle, and then pass in some named parameters. Pin color equals, you know, red, comma, pin size equals, you know, 5, comma, speed is equal to 7, you know, that kind of thing. That'd be pretty useful, right? You can create a turtle with all default characteristics, or you can set a whole bunch of stuff when you create it. Now, I swear you can do that, but I don't teach that syntax, and I couldn't find an example of it, so I'm not actually sure of the name of the parameters. And as a matter of fact, I'm not 1000% sure you can do that. But when we called the write method, to put text on our bar graphs, then there was the ability to also set the font and the size of it, and you would do that with named parameters. Okay, so that's enough of that. One more thing I want to talk about is list comprehension. That's a strange term. I'm pretty sure I haven't shown y'all this before. But the way list comprehension works, let me pull up an example to make absolutely sure I get it right. List comprehension Python 3 is what if you wanted the ability to do an entire process on a list just in one line of code. I'm not spotting it right away. That is not list comprehension. That is. So let's go ahead and do that. Results is equal to, go ahead and put it in there, square braces, x for x in range 1 to 10, which is actually going to count to 9, right? And then just print out the results like that. Look what it did. It made an entire list with one command. What if we wanted those numbers doubled? Let's write a little doubler function. Define doubler that takes a value, wouldn't have to be called x, and returns 2 times x. And then we're going to use the same syntax again. Results is equal to square brackets, braces, doubler x for x in range 1, 10. And then print those out. I don't know why they called it comprehension. I get the feeling that there's some subtlety there that I'm not getting. But check it out. I'll go back to the code. But look at our list. The first list was the numbers between 1 and 9, and the second list was those values doubled. So the way I've always used this is to apply a function to every value, or to call a function for every value in a list in a single line. To do this any other way, we would have had to use a loop. Our loop would have looked something like this. Result is equal to empty list for x in range 1, 10, colon, result dot append parentheses doubler parentheses x in parentheses, right? That and this are the exact same code. They both do the same thing. Let's run it and make sure, but those are identical in functionality. But it's kind of neat to be able to write it in one line of code rather than 3. And then people like to kind of distort the use of this by leaving off this variable right here, and it would still process every function there. Let's write an example of that. Define say hello to name, and then this is going to say print hello, comma followed by that name, and now we want to print out a list of hellos. So, and this just looks like weird. Say hello name for name in, And then let's, inside a second pair of square braces, put Fred, Bob, Joe. And like I said, this is kind of a iffy permutation in my mind. This is getting to the point where I think we're being too clever by half. Yeah, we wrote it in one line of code, but okay. I don't see the real advantage because it would have only taken 2 lines of code to write it otherwise. But there it goes. It said, hello Fred, hello Bob, hello Joe. But we did have places where we needed to turn a list of strings into a list of numbers. Right? You've called split on a string, and you need to convert them to numbers, like floats, for example. You could do it all in one line. Let's go ahead and give an example of that. Let's define a string that's a series of, numbers. Now let's make a list that's equal to the split version of that string. Let's make sure that actually works. Sorry, let me scroll that up for you. Yeah, no syntax error there. Alright, now say you wanted to build another list that was the same version of that, but converted all to floats. You could do this. L is equal to, and we're going to use list comprehension, so we start it with the list symbol, float of the string value, float of v for value in list, like that. And then if we print out L afterwards, it should be all numbers. If we printed it out beforehand, it should be all strings. Yeah, I was worried about that. Okay. So since I separated these with commas, I need to specify the separator like that. Or I could take the commas out and it would behave as default. I think I'll do that. I'm going to take all the commas out from my S is equal to, and then when I call split, it's just going to look like that. L is equal to S dot split. And there we go. We turned the list from a list of strings into a list of floats. And could you do that another way? Yeah, of course you could, and you probably already have in your assignments. But it's doing it in one line of code rather than 3, which is what I think it would take to do any other way. That's a very Python-y way of doing it. I don't recall seeing the syntax in a lot of the C-based, I should say in any of the C-based languages. It's not to say that they're not, but that's more of a functional programming style than a imperative programming style, which is what C++, Java, things like that are. Okay, so we've done list comprehension. List comprehension is when you use the square brackets around something in this syntax, and the way you do it is you put your for statement at the end of it, you use the variable that your for statement would be generating there, and then if you want to, if that function is returning anything, then you could store the results in another list like that. If we didn't store the results in a list, then when we printed L, it'd just be the same thing as it was before, because although we iterated through it calling float, we never stored those results anywhere. Alrighty. Anybody need syntax correction? Guess we're all good. Alright, I'm going to make a new file, and we're going to start talking about objects. We've been using objects all along. We've created a turtle, and don't type this, but once you create a turtle, you can call like t.forward. Yeah. Why am I saying don't type this? Because I'm just going to erase it immediately. Send that turtle forward, and then you can set his speed equal to 50, you know. So we have all these functions that's attached to a specific piece of data. You know, you create your turtle like that, t is equal to turtle.turtle, and then you can start issuing commands on them. These functions have a special name. A function that is attached to a piece of data is known as a method. So these are actually methods, not functions. All right, I'm just going to delete that, or at least comment it out now, because we're not working on a turtle drawing program at the moment. But what if we wanted to be able to do something like this? Rectangle, or no, let's do R is equal to rectangle, 10 comma 20, and then print R dot area. Right? What if we wanted to be able to do that? Now that's not, yeah, I left the L off, rectangle. Okay, rect. That's easy for me to type. R is equal to rect, like that, and then print R dot area. Or, you know, R2 is equal to rect, like that, and then, why did I say R and then type in T? And then R2 dot X is equal to 10, I keep typing that T. And then R2 dot Y is equal to 20, and then print out the area of it, right? That would be really cool. That's what's known as object-oriented programming. R and R2 are objects. The class is rect. R and R2 are objects of type rect. Turtle is our class. T is a reference to the object of that class. The class is the blueprint. You have a blueprint for a house. Then you actually go and build a house. That's the object. Then you build another house, identically the same, from the same blueprints. You have 2 objects. You build a third house. You know, you have 3 objects. Just like we could have had 3 turtles or 4 turtles, you know, in a single program, just by calling this line over and over, giving them different variable names. We could do that. Alrighty, since I'm not convinced that we're going to be able to get that stuff to work, I'm going to comment all that out for now. But we may bring it back. We're going to define our class up here at the top. But we're going to do a simple one first. We're going to do a circle. And this is in the textbook, the online textbook. Yeah, we could do the rectangle pretty easily. So what we're going to do, but we're going to do a circle first. And the circle only has one variable, dot radius. So we want to be able to do this, and I'm not going to delete this. We are going to get it to work. C is equal to circle, like that. And then C dot radius is equal to 10. That's how I want it to work. Let's see if we can get that to work. The way you define a class is you use the class keyword, then you give it a class name and a colon, and then we have to define an initializer, a constructor. C++ and Java call them constructors. I'm called it an initializer because that's the keyword that we're about to use. But this is what's known as a constructor. It makes an object of the circle class. So DEF, and when you see me type these underscores, they are 2 underscores. Underscore, underscore, init, underscore, underscore, parentheses, self, in colon. And honestly, this variable doesn't matter as long as you used it consistently through the rest of the method. So self.radius is equal to 0. When we create our circle, it has a radius of 0. Now let's define a getArea function. When we call getArea, it's going to calculate, you know, pi r squared. So define getArea, and again we need to use that self, parentheses self, end quote. The area of a circle is equal to self.radius times self.radius times pi r squared, times 3.14159. And then return that area. Let's add a print statement down here so that we can get the area of it. Area is equal to c dot get area, like that. I type that in below c dot radius is equal to 10. And then print area of circle is in quote comma area. And I'm going to save this, call it November 7b.py, run it once more, and check it out. It did calculate the area of a circle. Why do you care about doing it that way? Couldn't we have calculated the area of a circle in a simpler fashion? Yeah, we did, but you could create a whole bunch of different circles and then keep track of them all the same way. You could make a list of circles. I don't know if I want to talk about parameterized constructors yet. I kind of think I do. Let's write a new version of the init method that will take a value. And the reason I want to do that is because I want to be able to do this. C2 is equal to circle 5. Okay, that one has a radius of 5. C3 is equal to circle 10. That one has a radius of 10. That's what I want to be able to do. This doesn't support that yet. If I ran it, it would give an error. Boom. So let's do that. We're going to define another init method, underscore init, underscore self, comma, radius, colon. And then inside that method, self.radius is equal to the radius that gets passed in. Let's create a couple more circles just for fun. I guess I should have run it and tested it to make sure that's not a syntax error. Do that first. Okay, what's happened here is now it's wanting this to have a argument as well, because we have this one which is taking that, and we have this one which is not taking an argument. So to fix that, since I got an error here, is we're going to use a default value. Surely I've talked about default values. Have I talked about default? Okay, fine. I've got to talk about something else. Okay, so this is actually, I won't say more important, but this is something that we should have been talking about before I started talking about named parameters and parameter lists. You can give a variable, a parameter, a default value. So we're going to wish somebody happy birthday. Define b-day, parentheses, names equals, or not names equals, yeah, that'll work. Name is equal to whoever you are, colon. And then we will print happy birthday, comma, end quote, comma, their name. Now when we call b-day, we could call b-day and tell Sue happy birthday. We could call b-day and tell Bob happy birthday. Or we can just call b-day all by itself. If I call it all by itself, name, this parameter here, since there's no argument here, it's going to get this default value instead. And so it's going to print out happy birthday, whoever you are. And I'm still getting my error about the circle class, but here we go, right? We passed in Sue as an argument, we passed in Bob as an argument. When we passed in nothing, the name parameter picked up that default value of whoever you are. So that's a default value. Default value for a parameter. If no argument is passed in to this function, the name parameter will get the default value. We're going to take advantage of that so that we can pass in the radius, but if we don't pass in a radius, it gets set to 0. We all good, or are we getting syntax errors other than that circle call? That circle call has to be fixed. Okay, I'm just going to give the fix for that, and then I'll go back and help. Okay, to fix the error that I generated, that one's giving us an error. Delete that first init call, or we could delete the second one. But anyways, delete that first init method, and on the second one, add this. Radius is equal to 0. We're giving a default value for it, or maybe 1, or whatever you wanted your default value for the radius to be. But that's what we just added right there. That's what our init method should look like. Run it, make sure it works. Yep, okay. Pause. So a common thing to do is to actually set it up so that you have named parameters. So that when you created a circle, and don't bother to type this because we're not going to go in and set it up to actually work. But so you could do this. C4, like I said, don't type it. Radius is equal to, 5. And then if there were other attributes for a circle, I don't know what, but if we were writing a graphics program, you might want to set the color of the circle or its XY position or something like that. All right, so we've defined a class. We had ambitious goals of creating another one, a rectangle class that would support that code. We can do that, no problem. This one's going to take 2 arguments. So when we define its constructor, its init, it's going to have to take 3 arguments. Because notice this, each one of these methods has a parameter called self, but we don't fill that in when we call it. When we called getArea, we didn't pass something in. Python itself copies that in. So we're going to define our rectangle. DEF. Your classes ought to have uppercase names, by the way. So when I did this down here with lowercase r's, it wasn't too cool. Define rectangle. Excuse me while I scroll up and make sure I get the syntax right. No, it's not a define, it's a class. Class rectangle, parentheses, end parentheses, colon. Now let's write an init method. Define underscore underscore init underscore underscore parentheses self comma x is equal to 0, y is equal to 0. So if they pass in parameters, great. If they don't, we'll give them default values. I forgot the colon at the end of my define. So self.x is equal to x, self.y is equal to y. And we care about 2 things about rectangles. Their parameters and their areas. You raising your hand or? No, no, okay, cool. So let's write another function called getArea. It's not underscore, sorry. GetArea. Every method you define for a class has to have the self, but it doesn't have to be called self. But it gets confusing. People look at you weird if you don't. But what if you just called it O for some reason? It would look like this. Area is equal to O dot x times O dot y. Java programmers and C programmers would be tempted to use this keyword, in which you would use this dot x times this dot y. I'm going to leave it like that. Do I want you to do it that way? No, you ought to use the self keyword because that's what 99.999% of the programming populace out there do. But this is arbitrary. That name can be anything you want it to be as long as you use it consistently in that method. So we've defined get area. Now we're going to do get perimeter. One more. Define get perimeter self. I'm going to go back to using self, colon. Now the perimeter of something is equal to 2 times this dot x. Nope, not this dot x. I already started messing myself up. 2 times self dot x plus 2 times self dot y. There are other ways to calculate the perimeter, of course, as well. You could just do x plus y plus y and then return that. That's our rectangle class. Let's create a few rectangles. Matter of fact, let's create some rectangles and add them to a list. R1 is equal to rect with a capital R, 10, 10. It's a square, really, isn't it? R2 is equal to rect with no values. R3 is equal to rect 20, 100. R4 is equal to rect 50, 1. Whatever. Now let's make a list of those rectangles. List is equal to square braces R1, R2, R3, R4. Now, are we going to use list comprehension, something fancy, in order to print out the areas of this, or are we just going to use a for loop? I just say let's use a for loop. For R in L, and I just chose R arbitrarily to represent rectangle. Print area of rectangle is, end quote, R dot get lowercase area. Get area, parentheses, in parentheses. And let's do the perimeter of it. Just like that. Print perimeter of rectangle is, end quote, R dot get param. I'm indenting just a little bit to try to get it all on the screen. You don't need to do that. And let's just print out the x and the y of the rectangle as well. Print rectangle is %d by %d, end quote, %, define our tuple with parentheses, r dot x, r dot y. Like that. So we're going to print out, all that information about every rectangle on our list. I'm going to do something a little bit to this. I'm going to take out the words of rectangle and I'm just going to say area is and perimeter is. Why? Just reduce the verbal noise on our output. And also I'm going to put a couple spaces in front of those two words, area and perimeter. Why? So that when it's printing it out, it'll be clear to see. All right, I'm going to run it and hope I don't have any syntax errors. It's quite plausible I do. Nope. So it processed our list. A rectangle 10 by 10, the area was 100, the perimeter was 40. That one that we created with no size, 0 by 0, the area is 0 and the perimeter is 0. The rectangle that's 20 by 100, its area is 2,000, that's correct. Its perimeters, yeah. And then the 50 by 1, its area is 50 and its perimeter is 102. All right, so what I want y'all to do in class, except that we ran out of time, if I was going to give homework over classes, this is what it would look like. Write a class called Sphere. It has a variable. By the way, when it says self dot whatever, that's called a member variable, or an instance variable named radius. It has two methods, get area and get volume. And of course, get area returns the surface area of the sphere. Get volume returns the volume of the sphere. And the equation, the formulas for those are pretty easy to find. Just go to Google and type in volume of sphere, and boom, it'll show you the formula. You can Google the formulas for surface area and volume. Then have your code create a few spheres and print out their surface areas and volumes. And this is all based on, you can look this chapter up in our, so actually the last chapter of our online textbook. I think it's 15, but I wanted to get it. Yeah. No, it's not. There is one more chapter. Cool. Databases. Wasn't planning on doing that. Okay. And so this is chapter 14 online. Alrighty. That makes sense, guys. Based on what we've already done, this should not be terribly traumatic. It looks a lot like the circle class, right? It's only got one piece of data, the radius, just like the circle class had. It's just got two functions, two methods, rather than one. All right. Stop the recording. Oh, by the way, you'll notice that I did go ahead. I fell into the dark side. You do have one more bar graph assignment using dictionaries and letters. So I give that one every year, so I couldn't let y'all slip by without it. How about that?